what's the first thing you've done, for those of you who have actually gotten past drawing your axes, what's the first thing you've done to this to help you with getting a picture? Suggestions? Okay, so you've got a factorization, namely x plus 2 and x plus 3, right? Now, think back to last week. I know it's been a little while. You've had many maths lessons since then. It's one of the funny things about enrichment. But one of the reasons why we factorize, remember I gave you a big thesis last week, and I said factorization is not just a process you do because you can. It reveals something about the object you're looking at. It reveals something about the structure of a number or the structure of some algebraic expression you've got. So you factorize now. What does that reveal to you about the structure of this object? What can you see here more obviously than you could see here? I asked before, on a graph, what are the important things you're going to need to include on your graph? And the answer you supplied me was the intercepts, right? The intercepts. Now, this form here shows us those intercepts. Well, at least it shows some of us. Which intercepts does this show? This shows us the x-intercepts because it's factorized in terms of x. By the way, if you want to get the y-intercept, you just look at this. This form is already ready for the y-intercept. Do you see that? Because look, there he is, right there. How do you get the y-intercepts on anything? What do? You let x equals 0, right? Which gets rid of all of these terms, leaving you just with 6. Are you happy with that? So I can see -2, -3. Let's try and do a reasonable scale here. So I'll call that -2 and -3. I could go ahead and I could draw where 6 is according to this same scale, but I'm going to cheat a little bit and point out to you that horizontal axes need to be in scale internally, vertical axes need to be in scale internally, but they don't have to be in scale with each other, right? Like this could be 1 unit horizontally, but it doesn't have to be 1 unit vertically, okay? Because depending on the graph you'll get, sometimes that's silly, you shouldn't do that. Come in. Do you want to come around this way and grab a seat? So therefore what I'm going to do is I'm just going to draw through here, make sure I hit these, and then wherever I intersect with the y-axis, I'm just going to make that 6. Does that make sense? So here's my picture, or here's my attempt anyway. There you go. So rather than try and say, oh, 6 should be here, and then try and like wave around my parabola so that it gets to that point, I'm just going to draw the nicest sort of curve that I can do, and then just say, okay, there's 6. Okay? Right, when you have a look at the next couple, we'll do this a bit quicker. What's the factorization of number 2? What do you do with this? Pair of numbers?
X -3.
Yeah, x minus 3 and x plus 2. Okay, so it shares one of the roots from the previous one. So again, if I try and make this scale reasonable, we'll call this -2 over here. And then I'm going to go 1, 2, 3 over there. So now when I draw, I've got these 2 points to hit. By the way, just going back to this guy over here, did you notice parabolas are all symmetrical, right? Perfectly symmetrical horizontally, right? Which is why you can draw in an axis of symmetry if you wanted to. So when you have a look at this guy here, right? The axis of symmetry. Where is the axis of symmetry? Where will it be?
-2.
It's going to be, so I'm going to be halfway between these 2 spots, right? Do you see the axis of symmetry will be halfway, I'll draw it in actually, will be halfway between these 2. Okay. So when you have a look at this, is the axis of symmetry going to be on this side of the y-axis or on that side? It's going to be to the right, isn't it? Just a little bit, okay? The reason that's important is because when I draw my parabola, I want to make sure I get the vertex, that bottom part, in the right position, okay? So I'm going to do something roughly like this. Do you see? My axis of symmetry is just off to the right. My vertex is just off to the right. It'd be a problem if we drew it on the axis or to the left. It wouldn't be symmetrical anymore. What's this point here? Again, you can tell me just by looking at it in the original form.
-6.
Very good. Okay, now this last one is a little problematic because you go to factorize and what happens? what would you do with this? Yeah.
And you put it into the formula.
Okay, so you can put it into, well, let's rewind a little bit. The reason why you might think of going to the formula is because you can't think of a pair of numbers that adds to 2 and multiplies to 4. Come in, Farmer.
Sorry.
Come around and grab a seat. So you're in trouble just thinking in pairs of numbers like we could here. Okay. So therefore, you go towards the formula. Okay. But then you go to the formula and something else occurs, which is. Say it again. Say it again. Okay. So in the scheme of numbers that we're working with, you don't get any solutions, right? I'll come to this idea later on of what actual solutions you get. Now, if you go to the quadratic formula, I'll squeeze it again. If you go to the quadratic formula and you get no solutions out of it, at least no solutions that I can graph, what does that mean? What does that mean? For my graph, what is it? Yeah.
It's not touching the x-axis.
Yeah, very good. You can't get a solution for x, which means it never collides with the x-axis, so it's floating somewhere up above here. Okay. Now, remember I said to you that factorization reveals the structure behind an object. Okay. But there are lots of ways to factorize things because there's lots of different structures to objects. So let me show you how we would go about this. I'm going to show you it in a quick version. I'm not going to go through the details because you'll encounter this in a topic called locus and parabola next year. But I will show you what I actually do. I just won't explain exactly why I'm doing it. I'm going to write this first like so. Do you agree that 4 is 1 plus 3? Okay, I haven't done anything dramatic. Okay. Move this out of the way. I've got to wind it. Now I'm going to do two things. Watch carefully. What I'll end up with is factorized. It's just factorized in a different way. Okay. So first I'm going to take that plus 3. I'm going to subtract 3 from both sides. So I'm going to write it like that. That looks like it's a bit pointless, but stay with me. When I have a look at the right hand side, having subtracted 3, what am I left with? What is that? You recognize that, don't you? That's think back to last week. This is a perfect square, isn't it? It's the square of what? Okay. Now this is factorized. It's factorized in a different way. It's certainly not what we're used to over here, where we just have a y equals on the left-hand side. But it's factorized in a way which is useful to me because I can read off of this that this vertex point that I've been looking for, that I've been referring to, is right along the axis of symmetry. I can read off this that the vertex is going to be at -1, 1, 2, 3. It's going to be there. Do you see how I can see that? Can you see where that comes from? I'm looking for the point that makes this 0 and the point that makes this 0. I should say the coordinate. Okay? So the x-coordinate that makes this 0 is -1. The y-coordinate that makes this 0 is 3. So that gives me my coordinates. And then I can draw my parabola like that. What's this point going to be, by the way? Look again, original line. It's just going to be 4, isn't it? So that's my graph.